Hello everyone. My name is Vivek. I am a software developer. I make videos about containers, Kubernetes, Go as a programming language, or distributed systems, and sometimes about software engineering in general. So, if you have been liking the kinds of videos that I make, you should consider subscribing to the channel and you should follow me on Twitter as well. In this particular video, we are going to continue writing the operator that we have been writing in some of the previous videos. But before that, let's quickly go ahead and try to summarize what are all the things that we have already done as part of previous videos. So we were already able to generate the client set, tape copy, and other respective code for the new type that we introduced as part of this operator. Apart from that, we were also able to implement the code where if we create a custom resource of type cluster Kluster, a respective DigitalOcean Kubernetes cluster was being created, and we were also able to introduce sub resources in that custom resource so that we can update the cluster ID of the DigitalOcean cluster and whether the cluster is running or not. So these are all the things that we have already done as part of previous videos. So if you have not watched them, I highly recommend you should watch them first before continuing with this particular video. In this particular video, we are going to look into basically three things. So as of now, as soon as we create a Kubernetes cluster resource, a respective DigitalOcean cluster, Kubernetes cluster gets created, and obviously the cluster resource that gets created, we update the status of that resource to reflect the cluster ID and the status of the cluster. But we do not actually wait for that DigitalOcean cluster to get completed so that we can update the status of the cluster resource reflecting that this particular cluster has been created. So otherwise, how would we know that the cluster that is being created on DigitalOcean has been completed? So for example, let me quickly show you what I'm trying to say. So for example, if we run the operator and if we go ahead and try to create, let's say, this particular cluster resource, obviously a cluster would get created on DigitalOcean, and we also update status of this cluster resource that gets created with the cluster ID and status of the DigitalOcean cluster. So in this particular video, first of all, we are going to wait for that DigitalOcean cluster to get completed, and then we are going to update the status of the resource. So let me very quickly show you the things that we were able to achieve. So for example, if I run cluster here, so first of all, we will have to create the CRD. So kubectl create -f, and CRD is in this particular folder, and this is the CRD. And as soon as the CRD is created, let's go ahead and run the cluster. Now that the cluster is running, let's go ahead and try to actually create a cluster resource. So kubectl create -f manifests and cluster1. So if I hit enter here, a Kubernetes cluster resource would get created. So if you see here, our operator was able to figure out that a cluster resource was created, and it has created a Kubernetes cluster on DigitalOcean. And if we go ahead and try to get cluster named cluster-0, because this is the cluster that we created here, we should be able to see cluster ID and obviously progress. So describe cluster 0, And here if you see, for status we have cluster ID and progress. So first of all, what we are going to achieve is we are going to wait for the DigitalOcean cluster to get created, and then we are going to change this progress to running, so that anyone who created this cluster resource can describe this cluster resource to figure out that, okay, now DigitalOcean cluster has been created and is running successfully. So let's go back to the code here, and if we see, we are just calling DigitalOcean.create, and then we are updating the status, but we are not actually waiting for the DigitalOcean cluster to be up and running. So to wait for DigitalOcean cluster to be up and running, what we will have to do is we will have to query the DigitalOcean API, let's say in a certain interval, to make sure that the cluster is up and running or not. So to do this exact thing, either we can obviously write our own code, but I'm going to use this open source project that I know, and using that open source project I can easily do the exact same thing. So we will have to query DigitalOcean API to make sure clusters state is running. And as I said, this thing can be done manually, we can write the code, but I'm going to use this open source project that I know. Okay, so this is the package that we are going to use, and from poll.co, this is what we have to use. So if you see here, we can pass a function to this particular function that is from poll module, and this wait is going to call your function until and unless it returns true. So this is what we are going to use. You don't have to worry about this. We are eventually doing this. You can write your own code as well. So let's import that. So let's say we have to call c dot wait for cluster and from wait for cluster we have to call poll.wait, and this obviously expects a context and a function. So let me quickly go ahead and try to just go build it so that we would be able to download that dependency, and we can actually, so if you see here, we are downloading canister. I think we are going to face this problem. So canister uses another dependency, stove, and the version is uh, manually hard coded in their dependency file. So to resolve that, what we are going to do is we are going to have this in our, we will have to explicitly specify the store version that we want to use. And if I go ahead and try to run go build again, this is going to pass now. So again, let me try to summarize this. So we eventually are trying to do this, but I want to use another open source project to do this, but you can obviously write your own code to achieve this, to wait for the Kubernetes cluster to be up and running. So if you see here, it obviously says Paul.wait wants context and function, but just have but nothing is being passed. So let's pass context, and we will also have to pass a function. Now, as I said, this function would get called, the function that we are passing, this function would get called uh, unless it returns true. So what we can do is, in our digitalocean.go, we can have another function, or another function that gets the status of Kubernetes cluster, and we would return false from here if that cluster status is not running. So let me try to explain that once again. So this function is going to get called until and unless it returns true. So what we can do is, we can call DigitalOcean API and we can return false if the cluster state is not running, otherwise we can return true. So let's go ahead, and in do.go we will have to have another function named, let's say, cluster state. And clusters, to get cluster state, we have to do this exact same thing. So we are going to expect spec as well, and so this is going to expect cluster.spec, and we are going to create a token as well as client. Alright, and it returns, let's say, it is going to return either cluster state and error. So we have DigitalOcean client, and let's just go ahead and try to figure out, if we have DigitalOcean client, how we can figure out a specific cluster's state. So there is this get method here, retrieve an existing cluster, and that is what we are going to use to figure out a cluster state. So if you see here, we can call client.kubernetes.get, and we can obviously pass cluster ID to get the cluster details. And if you see in the response, we have status.state that tells us the current state of the Kubernetes cluster. So that is what we have to do. So client.kubernetes.get, so client.kubernetes.get, and I think it expects context and string. So context, and this would be cluster ID. So we are going to expect cluster ID as well, and let's pass ID from here, and it returns cluster response and error. So cluster response and error, and we can simply return, we don't exactly have to do anything with response, but we can return cluster dot status dot state and error. So if error is nil, we are going to return nil, otherwise we are going to return error. And from cluster, what we can do is, we can say do dot cluster state, and we are going to pass c dot client, and we are also going to pass spec of the cluster that was created and cluster ID. So we have to pass cluster spec, and we also have to pass cluster ID. Alright, and it returns state colon error. So if error is not equals to nil, in that case we obviously have to return false comma error. But if state is equals to running, in that case we can pass true comma nil. So alright, I hope this makes sense. Now let me clarify one thing here. This is not the very good way to write this particular code, because if you see here, we are trying to get the token in client here and in this particular method as well. So I think it would be a good idea if we can create a struct. That struct can have fields like client, etc., and then these particular methods create cluster state can be bound to that type, or these can be made method of that particular type. So yeah, I mean, this can obviously be refactored. Now we are calling wait for cluster, and the context that we are passing. So we can actually configure that we want that cluster to be running within, let's say, 10 minutes. Otherwise I want to cancel the execution. I don't want to wait longer than 10 minutes. So let's create a context dot with cancel context, or context with timeout, and this is going to have a context and obviously timeout. So I'm going to keep the timeout to be 10 into time dot minute. So this is going to give us context dot cancel defer cancel, and let's pass this context here. So it simply means that we are going to wait for the cluster to be up and running within 10 minutes. Otherwise we are going to wait for that particular cluster to be up and running. Now that we have waited for the cluster to be up and running, we can obviously expect an error to be returned from this. So wait returns an error, and this is what can be done. And if error is not equals to nil, in that case log dot printf error waiting for cluster to be running, and error is, here we go. If cluster is running successfully, what we want to do is we want to update the status again, but this time with the status to be running. So let's do that. So c dot update status, and this is going to be cluster ID, and status is going to be running, and we want to update this particular cluster. And again, if error is not equals to nil, in that case, we obviously there are chances that we would want to retry these things, but right now I'm just logging these things. But obviously, we in production scenarios, when you are writing a code or controller that is going to run on production, you might want to retry these events. We can discuss about them in a bit maybe. So log.printf error percentage s updating cluster status after waiting for cluster, and error is this one. So yeah, I think we are good here. Let's go ahead and try to run this, and we will be able to make sure that cluster state is being updated, and as soon as the cluster is up and running. So let's go ahead and try to build the code once again. Okay, now that code is built, let's go ahead and okay, so now if you see, I'm going to create cluster 2, and as soon as obviously I hit enter, our operator would be able to figure out that a cluster resource was created, and it would try to spin up a respective Kubernetes cluster on DigitalOcean. So here we should already see one that is cluster 0. Now if I go ahead, yeah, and we deleted cluster 0 event from here, but even though cluster 0 is running in running state, the status would have not been updated. So that is what we are going to demo now. So cluster2.yaml, and we have the cluster ID, and if we describe this particular cluster or describe cluster-1, we should see cluster ID and status, but that would obviously be in creating state. Now let's go ahead and look at the console for a second. We would have cluster1 in creating state, and as soon as this cluster1 is created, we should be able to see the status dot progress to be running. So let's wait for a second, and then we should be able to see this progress to be running. So I'm going to pause the video for a second. So what I've done here is I ran kubectl git for the new cluster resource that we have created, and I am just trying to get dot status dot progress, because this is where we get if the cluster has been created or not. So if you see here, we are seeing create here, and as soon as this particular cluster1 is created, we should see this being changed to running instead of creating. So it looks like we just have, it's just going to take maybe 5-10 more seconds, and we are seeing creating here. If everything goes fine, as soon as this particular cluster is created, this state should be changed to running instead of creating. And we are also going to look at the logs just to make sure that things are working as expected, and we are not nothing is broken at the code level. All right, so it looks like we have a problem. So for example, if we see here in the logs, it looks like the operator that we are running, that operator tried to update the status of this cluster 1 object but got a problem. It says the object has been modified, please apply your changes to the latest version and try again. So it simply means that when we, for example, when we called wait for cluster and then when we called update status again, the cluster spec or the cluster object that we have has already been updated, and that is the reason we are not able to update the already updated object, because obviously there are chances that we are going to override someone else's changes. That is the reason it says updation failed. And to resolve this, what we are going to do is we are going to change the implementation of update status a bit. So even before running update status, what we are going to do is we are going to first get the cluster or latest version of cluster and then update that cluster. So let's try to do that. So we are going to say c dot client dot v1 alpha 1 dot clusters, and the namespace is cluster dot namespace dot get, and it expects context and it expects name. So cluster dot name, and then meta v1 dot get options, it returns cluster and error. If error is not equals to nil, in that case we can return error. Otherwise what we have to do is we have to now update this particular cluster instance instead of this cluster instance, right? So let's try to do that. So we have to change the cluster ID, we have to change cluster status, and we also have to pass here k instead of cluster. This looks good to me. If we go ahead and try to run this, things should work now. So let's go ahead and try to build this again. So go build, and we would run cluster again, and we would create another cluster resource. All right, so cluster, and let's make a copy of cluster2, name cluster3.yaml, and let's change cluster3.yaml to name it 2, and this should work. So let's go ahead and create this cluster3.yaml, and this time things should work as expected. So if you see here, cluster2 was created and DigitalOcean API was called to actually provision the cluster. We have the cluster ID, and if we describe the cluster, if you see here, the progress is creating, but as soon as the cluster is created on DigitalOcean, this should have been changed to running. So let's use the same command that we used last time to actually just look at the status and watch that. So hyphen get cluster hyphen o JSON paths equals to dot status dot progress. Alright, so status is creating and the cluster is being created. If we refresh this particular page, a new cluster named cluster2 should be there with the status creating. So here we go. Now, as soon as this cluster 2 is successfully created, this status should be changed to running without any issues this time. So again, let's wait for this cluster to be up and running. All right, here we go. So if we see here, the state has successfully been changed to running instead of creating. So if we describe the cluster once again, the progress is running instead of creating. So this is what we wanted to do. Let me very quickly go ahead and try to summarize what we have done as of now. So this was already implemented. We called DigitalOcean API to create the Kubernetes cluster, and then we updated the status of the cluster using c.update status. But in this particular video, we have implemented wait for cluster, and to actually wait for cluster, we have used an open source project. And this project has a function wait. This wait calls a particular function. So this particular function, until and unless it returns, so it waits for this function to either return true or waits for this timeout to get completed, right? So this is what we have used. We wait for the cluster, and as soon as we know that cluster is running, we update the status again. While updating the status, we faced a problem. We were trying to update the status of a cluster resource, but the cluster resource that we were passing was already changed. That is the reason we introduced this particular logic to get the cluster again from the cluster, get the cluster resource again from Kubernetes cluster before actually updating it. So now that we have implemented it and we see that it has been implemented, the other thing that I wanted to talk about is how do we actually record events. So for example, if I, let's say, go ahead and try to create a deployment in default namespace, we would get this deployment. And if we, for example, describe deployment, if you see here, we see this particular event, right? So event type is normal, reason is scaling replica set is, and this actually tells who generated this particular event and then the message. So when if something goes wrong, this is a very, I would say, good way to debug that particular issue. If something is not going as expected, if we don't see expected number of replica sets, we would like to describe a replica set. If we, for example, if our volume is not coming up, we would like to describe persistent volume or claim. And there or under events, we would see all the events generated by all the controllers, let's say, that are responsible to entertain that particular resource. So if we talk about deployment, if a deployment resource is entertained by, let's say, n number of controllers, all those controllers are going to generate their events for this particular resource. And if we, for example, describe deployment, we can obviously see the events. Similarly, if we describe pod, we can see other events as well. So if you see, as I said, all the controllers or all the entities that are responsible to do something for this particular resource, they update their events for this particular resource. So we see here default scheduler updated that this particular pod was assigned to this particular node, and kubelet updated that it is pulling the image. So this is what we are going to implement now for our custom resource and operator. So as soon as we call do.create, we can update that. We can generate an event saying that DigitalOcean API has been called to create the cluster. And as soon as we know that cluster has been created, we can update that cluster has been created. Now in this particular example, these things are going to be redundant. For example, we have the same detail in status, we have the same detail in events, but I think you know why we are trying to do that, and you would be able to figure out use cases. In this particular video, I'm just going to show you how we can achieve that. So for controller, if you see here, we have all these fields. Similarly, we are going to have a recorder for this particular controller. To do that, let's go ahead and try to again refer to a particular project that I have already written, that is Krius. So inside controller, this is how we can do that. So we will have to have a recorder field. So let's name it recorder, and the type is going to be record client go tools record dot event recorder. And once we have event recorder, we will obviously have to initialize it in this particular function so that we can use it in other functions. So first of all, if we go to the describe the describe resource again, if we see here, we also have to actually specify which particular component or entity generated this particular event. So to do that, what we have to do is, if you see here, we will have to register or add our controller type or operator type, so that when we generate an event, we would actually get who generated this event. So this is runtime, and we are going to call runtime dot must, and then we are going to add our custom scheme to the standard scheme. So if you see here, this scheme is actually a custom scheme that we generate, and this is the actual scheme from the distribution. So we are going to import this, and we will have to import a custom scheme as well. So if we go here for client set, this is the scheme that we are talking about, so we will have to import this as well. So let's go ahead and try to import this. So github.com K8S Kluster package client set version, and then we have schema, and let's call it custom scheme. So what we have to do is, we have to say custom scheme dot add to scheme and scheme dot scheme, and here we go. So this actually is registering or adding our operator type to the standard scheme. And if I save this, things should work as expected. And once we have done that, let's go ahead and copy these things. So we are just creating a new broadcaster, and then we are saying we want to we are setting logging, and we are also specifying the event interface. So let's copy this thing out, and then we are calling event broadcaster dot new recorder, and component in our case is cluster. uh, I think this should work. And once we have a recorder, we can okay, so we have to obviously implement or import typed core v1 and core v1, and we would also need cube client. So cube client is client, and then we have to have typed core v1. I think we already have typed core v1 somewhere, but let's go ahead and import that from here itself. All right, it looks like we have successfully initialized recorder. Now let's just go ahead and try to maybe just generate one event. So we are calling do.create. If error is not equals to nil, in that case we are saying error creating cluster. Otherwise, obviously, if there was an error, we would not want to progress here. We would want to maybe retry that, return, or something else, but we would not want to continue. So if we are continuing, it simply means that cluster creation was successful. So let's just go ahead and try to generate an event. So c dot recorder dot event, and this takes a lot of things. So if you see, it takes object, event type, reason, and message. So object for us is cluster, and event type is, let's say, event type is a string, and we can specify if the event type is a normal message, or it's a warning, or an error, something like that. So if we see here, it says type to be normal, and this is what we can specify from here as well. Now there are ways to specify those types. So for example, uh, core event dot event type warning, event type normal, so that is what we are going to use. So core event v1 dot event type normal, and then it expects reason, and let's say reason is cluster creation, and message is DigitalOcean API was called to create the cluster. And similarly, we would want to generate another event once cluster was created. So cluster creation completed, and the message can be DigitalOcean cluster creation was completed. Alright, now let's go ahead and try to build this again, and we will have to create another manifest. Okay, there seems to be a problem. So delete cluster. I'm just going to delete all the previously created cluster resources. And I am going to create a new cluster resource. Let's go ahead and describe that cluster resource. So cluster hyphen 3. My bad. All right, hold on. Okay, so yeah, it simply says that the cluster ID was not even created. So that is the reason a lot of things failed, because we don't have a cluster ID. So what we will have to do is we will have to delete these already created clusters. This should have already been handled. I mean, this should not panic even though things are not working. But yeah, I mean, this obviously is not how production code is going to be written. So yeah, so if you see here, now we see cluster ID, and we also see that an event was generated. Now if we go ahead and describe the cluster resource, cluster hyphen 3, we should see the event as well. But and this is what we actually wanted to do. If we look into previous outputs, where we wanted to describe cluster, we did not actually see in any event, and but now we are able to see that event. So yeah, we are obviously not going to wait for this cluster to be up and running, because we have already seen that. I think this is another thing that I wanted to talk about as part of this particular video. The other thing is, when we okay, so we have created a cluster resource, but if we delete this cluster resource, respective Kubernetes cluster on DigitalOcean should also be deleted. So we already have a handle delete method here, and I'm not going to implement that. I'm just going to show you how it's done, and maybe you can try to do that by your own. So if you see controller.go, we have to do the exact same thing that we are doing here. So in handle delete, we are adding the object, and in process item, what we are trying to do is we are checking if that particular resource is there in Kubernetes cluster. If that resource is not there in the Kubernetes cluster, it simply means that the cluster resource has been deleted, and then we will have to, instead of all these things, we will have to call DigitalOcean API to actually delete the cluster. So yeah, I'm not going to implement this. I am just going to maybe if you want to do that by your own, this is the project that you can refer, and I already have implemented the same thing in another playlist. Another thing that I wanted to talk about is, now that we are waiting for cluster to be up and running, and we just have one daemon or one go routine to get the values from the queue. So we are maintaining a queue, and we are running this particular daemon that gets values from the queue and processes them. So now that we are waiting in the same, I would say, daemon, or in the same routine, we are waiting for the cluster to be up and running, and that takes almost 5 to 10 minutes. If we go ahead and try to create another cluster resource, that request would not be entertained, because we only have one daemon that is getting the objects from queue and then processing them. So there are chances that you might want to run more than one daemons, for example 2 or 3, or you can even take that value as an argument to run method here. So I hope this makes sense. So for example, if we see cluster ID here, but if I go ahead and try to create another resource, so so if I create this now, handle add was called and nothing else is happening. And the reason is, even though the new resource that we created, new object that we created has been added to the queue, but there is no daemon, there is no process that is ready to entertain this particular object, because we are only running one daemon, and that is already entertaining, that is already handling this particular resource. So maybe you would want to run more than one routines here to get the values from the queue. So yeah, I think this video got too lengthy. I'm so sorry about that. If you liked the video, don't forget to subscribe and like the video. You should share it with your friends, colleagues. Thank you so much for watching, and I'll see you in the next one.